here we are back again, having a look at addition and some good place value methods for it. This next one is just, I call it long addition, but I'm not too sure why, but because it's probably long. But here's how it works. From some context, it might be another activity. I might be doing some measurement. I don't know. I might be finding out average heights, and I don't know. We have some numbers to add up. So because you're always looking for a context to have this sort of work make sense. So whether it's a game, whether it's a measurement task, or it's something to do with data, we have a group of numbers to add up, and we have 738, and we have 264, and we have 197. All right. What I can do with these numbers is simply this. So note I haven't used extended notation. So this is more like a step on. When we've nailed that, the understanding is high for the kids. You can now go on to do this. And it doesn't matter whether you start at the left or the right. It actually doesn't make any difference. Otherwise, we wouldn't have a commutative property or law. So we've got 700, and this is the thing now. I haven't extended the notation, but I want to hear from the kids. You might even put up your little, just a reminder symbols up the top, that this is what they are. So really reinforce that place value, because it is critical. Because I want to hear the kids say that's 7. I don't mind if they go 721, but I'd rather hear 700, 200, 100. That's 10 hundredths. Okay, so I've got 10 hundredths, or they say that that's 1,000, but I've got 10 hundredths. Okay, I now add this. I've got a double here. 3 and 6 is 9, and 9 is 18. You can put double in your keywords, and I've got 18. But it's not just 18; it's actually 18 tenths. So I've got 180, and I've got I don't know. Might as well go with my even numbers. I've got a near double. 8 and 8 is 16. So 8 and 7 is 15, and 4 is 19. So I write 19. And now I add again. A lot of kids will actually cut out this next step because they can already see the answers. The answer's quite visible there. So we'll go, I've only got 1 again in this column, that's 1,000. I've only got 1 here, so that's 100. I've got an 8 and a 10, that's 90. An 80 and a 10, that's 90. And I've got a 9. So I've got 1, 1, 9, 9. Yeah, so I add them again. I'm done. There's my total. I'm finished. So the first step the kids will take out is that one, because I just made those numbers up randomly, but they fell okay. The answer here is actually quite obvious at 1,100. Yes, I got 90 and 9, but that's the formal step of it. But that one can go. You notice it's avoiding all. No, putting a number down here. No, you don't get to write the number. You got to carry it to the top, which is, to me, is just so not a maths term that you carry it somewhere. You probably get to carry because it's clearly injured or malnourished because it's about 1/3 of its normal size. Like if this was 19, we put down a 9 and we put a little shrunken one up the top. Like, why? There's no place value about that. There's nothing about it. So don't feel bad if you've been doing it. It just doesn't make sense. That's all. So this is an alternative. I just call this long addition. But the first step that will shorten it is the kids who actually see this. So they might need this step for a little while, then they'll go, hold on, I know how this works. But it's not as wide, if you like, as a sum, because I'm just using the numbers without extended notation. So the kids are ready for this when they actually know, hey, that's 700, that's 30, I've got this, I know this. So yeah, that's long addition. And join us very soon, because we're going to be having a look at subtraction and some methods of it that I hope you'll go, wow, that's what my kids need. All right, see you shortly.